Well, good morning. My name is Vivek. I'm the Chief Technology Officer of Fujitsu. What that really means is I'm really responsible, I guess, for anything that Fujitsu does with technology, both from a strategic perspective and investment perspective, and what we bring to the world in terms of our innovative technologies. So today, I guess, it's a very important occasion because for us, it's really about how do we take that technology that Fujitsu has developed and continues to develop in our different labs and bring that to the United Kingdom and bridge and make that available to the society here, as well as, I would say, create a bridge between Japan and the United Kingdom, right? So it's really, I would say, as the statement over here aptly summarizes, connecting people, technology, and ideas to create a brighter future for the entire society. So what we are aiming to do here, and I think it's something that Fujitsu is uniquely positioned to do that, is to help build an innovation bridge between the two countries. And why I say that, because ultimately, if you look at Fujitsu's purpose, which I'll be talking briefly about, it has innovation as the key pillar that we continue to strive on. And you cannot have innovation without technology, right? So I think Fujitsu is in a unique position to drive that and build that, what I would say, bring the latest and greatest from Japan to United Kingdom. Now, if you look at the relationship between United Kingdom and Japan, it's really strengthened over the last few years, right? In October 2020, Japan and the United Kingdom signed an agreement, followed by you had Prime Minister Boris Johnson and Prime Minister Kishida lately, which said driving growth, creating highly skilled jobs, and ensuring we both remain technology superpowers. And I think from that perspective, the synergy that can be driven from what Japan brings to the table, from what United Kingdom brings to the table, I think it's pretty unique, because if you look at Japan, it's kind of to the, sits outside rest of Asia, part of Asia, and you have UK on the extreme west of Europe, and they both kind of evolved in their own unique ways while holding a leading position. And bridging that, driving synergy between the two countries is something that has a lot of benefit. We are working, both the countries are working on a shared vision, but I think that shared vision is also really, really underpinned by technology, because it is critical. It is critical that when you look at the innovation that has happened for Japan, that innovation has to become relevant globally. There's a lot of stuff that happens in Japan, very, very innovative stuff. Some of that stuff, in fact, a lot of that stuff stays only in the country. And I think it has to be brought out to increase relevance for Japan globally and for United Kingdom, but that technology plays an increasingly important role, especially when you look at the speed of digitalization of the society. We look at how the societies are evolving at a rapid pace, and the ever-increasing important role that technology is playing. So this just grows over, just driving the previous point that I talked about. And Fujitsu, as a company, I think we are hugely committed to United Kingdom and its future, right? I mean, from our perspective, global Britain and the ambition to continue to remain as a technology superpower. Japan has the same ambition. You look at some of the things that have happened in last 15, 20 years, both in the society, geopolitics, and you see Japan recalibrating itself and see, look, more massive investment in technology. Technology is the way forward. And you look at technology like quantum, artificial intelligence, of course, computing, processor technology, a technology that brings home human technology interface based on neurosciences, social behavior. That is something that I think is where Japan can really work with United Kingdom to help drive the future. This week at London Tech Week, right, we are very, very proud to announce the first phase of our investment to activate new Center for Cognitive and Advanced Technologies. Some of you might have already seen the announcement. We announced that we would be investing 22 million pounds as an initial investment. That's a major investment from Fujitsu. And that will help create 200 new jobs. But this is just the beginning, right? This is the beginning of a journey. From our perspective, what we see is the CCAT model is a model that immediately helps to leverage the technology, drive benefits for the society, right? It brings the government, it brings the citizens, it brings the businesses, and of course, Fujitsu together in areas like quantum, artificial intelligence, banks, other institutions that are involved. So I would say, the CCAT is oh, I want to make sure I'm on the right slide here. All right. So the CCAT is really a mechanism that helps access innovation from United Kingdom and the stakeholders here to what is being done by the research teams in Japan, but not just in Japan. Our Fujitsu global research bodies that are managed now very, very centrally. So you've already seen the benefits, for example, with our digital annealing technology, which digital annealing is not really quantum, but it is, I would say, I would call it the entry point into quantum, right? I mean, it is annealing, it's digital, but it is something that is commercial-grade technology. The UK Space Agency uses it to actually, resolve one of the issues, which are like space garbage, and actually commercialize that. We're seeing significant process with our work in the United Kingdom with our digital twin technology. We built over the last 9 to 12 months a technology framework for smarter cities that uses high-performance computing, that uses 5G and public 5, or what you call 5G for not for telcos, but for companies, for organizations. Get that data, suck that up, use it into digital twins, pump that data through HPC, create offerings for average citizens that we are building that framework in Kawasaki-city. Now, this is something that is a framework that can be rolled out to other cities. There's a business model that is built around that so that it's not just technology alone, but a business which involves average citizen. So when you build a smarter city, the biggest issue really is an average citizen like you and I involved in that. How do we see this beyond just words of smarter cities, right? And that is what we've done, and I think this is what we'll bring again here to United Kingdom. So I would also say that for Fujitsu, over the last 12 to 18 months, we've been doing research globally, driving technology innovation with our global centers in Silicon Valley. Of course, here we built 2 new centers, one in Israel, which is primarily focused on security, data security. We built another center in India, which is really leveraging the talent pool for artificial intelligence and quantum software. So it is really bringing that overall global technology piece that we are now managing to drive technology innovation even at a rapid pace over here. Just, I won't go through this, but I will just tell you three key words that I said in the beginning: innovation, trust, and sustainability. So this sets our overall direction. And when I say innovation, you won't have innovation without technology, right? Technology is at the center of everything what we do, right? And it's got to build trust, right? So you got to build technology that people can trust, that people are comfortable with, that society is comfortable with banking on, right? And then obviously it's got to be sustainable. It's got to be contributing to a sustainable environment. We firmly believe that sustainability is also good business. We announced the new processor for Fujitsu Monaka, which will be challenging 2-nanometer technology, right? Assuming our friends in Taiwan, TSMC, can develop that, right? Because nobody's done that before. But the key purpose of that processor is it will use 1/10 the power of what the processor in Fugaku uses. Now, Fugaku is an ARM-based processor. It's probably the only large supercomputer that is ARM-based. And when you see this Monaka processor, it'll be 1/10 the power. If we chose not to do that, we could have probably saved half the cost or half our investment in doing that. But we believe that's good business. Data centers will want it in the future, and it's a very open architecture. But that's what I mean, translating these words into action. So last year, around the October timeframe, when we had Fujitsu Active, we announced Fujitsu UMass. What UMass really is, it's 7 key solutions that are aimed on how do we make, contribute to the business of our customers and helping them become more sustainable. We did a survey, what we call the Fujitsu Technology and Service Vision, where we surveyed about 1,800. We surveyed 1,800 C-class executives worldwide in 43 different countries. And what we found is about 5% of them are, they're happy with the progress on what they're making in sustainable environment or their contribution to sustainability. 95% are still not there simply because they don't know what to do, what are the issues there, how to resolve those issues, how to bring the company along with it, and how to ensure that the business and sustainability, they drive synergistic balances. And that's what this is, sustainable manufacturing, consumer experience, right? Healthy living. You don't see those verticals from a normal organization. It is really, it's not like manufacturing or airlines or banking. It's healthy living. And healthy living is taking different verticals and bringing them together. You don't see banking up there. Does that mean Fujitsu doesn't do banking? Fujitsu is absolutely committed to banking because we believe banking and payment systems absolutely underpin every one of these, right? And these are underpinned by 5 technologies. Why these 5? Very simple story. That's part of DX, what I would call digitalization of society. You need massive amounts of computing power to do digitalization. You need networks to connect. You need artificial intelligence to get intelligence out of that data. You need that data to be secure. So a very simple story, nothing complicated. Our research efforts are focused on that. And then the last one is converging, where that's human sciences and technology, social sciences. I just talked about these 5 technologies and why these 5. In each one of these, what we will be driving in technology, Fujitsu has no grand illusions of like we are going to do everything, right? We will be partnering with a lot of organizations. But we will have core technology which is built by Fujitsu because we believe that's a differentiator that creates a value. But in each one of these categories, there are areas that we've chosen to focus our research on, and rest we'll just partner. In computing, our efforts are going to be focused on, for example, HPC and quantum inspired. We believe there's a room for all 3 of these technologies going into the future. Not everything is going to be quantum. Not everything is going to just remain on traditional compute, which we see represented by HPC. Same with AI. Every organization has an AI offering. Why Fujitsu? What's the value of Fujitsu? It is, as I mentioned, explainable AI, human sensing AI, cause and effect. Those are 3 areas we're really good at, and that's what we're going to focus on. Rest, we partner with others. Data security, it's digital blockchain security, digital trust technology. rest, it's partnerships. So each one of these, we are going to be like focused on being either number one or number two in the world in the technology that we focus on. In computing, as I just briefly mentioned, right, we are going to be focused on all these. We believe all of these have a future. If you look at what is, in terms of quantum, what is commercially viable today, it's really, the quantum, gate-based quantum is still not commercial grade, right? And it'll be a few years. It will get there. It'll get there. It'll probably get there faster than most people believe it will, but it'll be there. But today, the reality, it's not. So you have digital annealing, which, quantum, you use quantum for mostly optimization problems. And annealing is very, very, able to solve those optimization problems. Quantum simulator, we announced the world's fastest quantum simulator, 30-qubit, that uses the same technology that powers the supercomputer, A64FX. It's got ported the quantum freeware quantum simulation software on top of it. And that was announced in March. We will be announcing a 39-qubit or 40-qubit. As some of you might realize, every qubit you increase, the physical size of the machine doubles. So you kind of get to the end of, when you get to a 40-qubit quantum simulator, the limits of that. Now, there are problems like that you cannot resolve without pure quantum, like a traveling salesman problem. But there are a lot of things that you can. And what a quantum simulator does is have most organizations be ready with their applications to go to quantum when it's ready, when quantum is ready, right? Also, we believe when quantum is available, just the costs will ensure that there's a play for quantum simulation and digital annealing technology in the future. So we'll continue to invest in that. We just announced a 100,000-bit digital annealer. With the biggest problem with digital annealer from our customers that we heard was getting all the automation up front takes like 30 days. So we kind of did a lot of research work into it, automated most of it, and you can now get that up and running in 1 or 2 days. You just don't need all the experts from Fujitsu to come in and build that with you. It becomes much faster. And obviously, AS64FX, that's the HPC. We announced compute as a service for the market. Yes, so we announced compute as a service offering, and that's part of UVAN's offering in April of this year. What this compute as a service is, as I mentioned, it's really looking at the computing pool and making that available to the end users over public cloud as a service. Think about it. In the future, you have traditional compute represented by HPC. And I kind of shy away from using the word supercomputing because then you get that image of white-coated scientists with white beards sitting in a small lab doing their very esoteric things. It's not, right? I mean, HPC should be available to, the power of HPC should be available to normal daily businesses to resolve their issues. But not many people are going to be able to afford supercomputers. Not many governments can afford supercomputers. So it is what we are bringing. We make that available over Amazon and Microsoft Azure Cloud, right? Same with annealing and quantum simulator. And when quantum comes out from us, when commercial grade quantum comes out, we'll do the same. I already told you that we are investing in 3 technologies: gate-based, trapped ion, and diamond spin. And we work with different universities in Japan and globally. For example, with diamond spin, we're working with Delft in Holland, University of Toronto for annealing. But the point is, compute as a service, when the compute becomes this complicated, the end users should not be asked to decide, hey, my problem is best suited for quantum, or my problem is best suited for HPC. A normal user should not care where their problem is, resolved on a compute side. All they should care about is they get the answer in the quickest possible way, in the least expensive manner, and the most accurate answer. So this compute pool is what we are working on. The first 3 areas are already available. And the research that we've got, and I'm being very transparent, the research that we've got is building the middleware on top of that, where that middleware automatically decides, hey, this end user problem is best suited to be passed on to the quantum side or HPC, or the digital annealer. And it does that based on some energy-based calculations, VQ or NISC, for those of you who are familiar with that, right? And when I started this research, when I asked the team to start this research, I wasn't sure whether this is going to cut much ice. And I have to say, they've made some really good progress. This has not been done anywhere in the world, right? So they've made some good progress. We're running some POCs. We're starting to work with customers now to look into this. And if it materializes, which I hope it would really resolve a massive problem in saying, from a futuristic side, where people like a banker, an investment banker, how does he optimize his portfolio? He throws his problem, or drug discovery. They shouldn't be computer scientists. I mean, they should be pharmacists or drug discoverers or bankers who are using compute. Many examples. As I said, digital annealing, that's commercial grade, right? We made a bet about 10 years ago on this. It's now become commercial grade on digital annealing, 31 cases in Japan, use cases 55 outside Japan. You see that some of them, again, high performance computing, that's being used massively now. It is, a week and a half ago, I was in Hamburg at the HPC conference, and you can see, when you see companies like NVIDIA and Intel and all the massive compute companies investing heavily in this area, you can see this is going to have a major presence, impact in the coming future. So Fujitsu is very well positioned. You see, this one. I've talked about this. I think it's a wonderful example. It's a great example of how digital annealer, which is has been used by the UK Space Agency to space debris removal. I mean, when we built this, obviously we didn't think about this sort of an example, but it's amazing, when you put this in hands of the end users, what they come up with. But 25 faster, mission, and 18% less fuel. I mean, that is massive. That is massive, right? I talked about the quantum simulator. I think that is, we were very well positioned to build this. And I think it did surprise a lot of our competitors, as well as our partners that we built. We built this in a time of 9 months, or even less, because we had all the building blocks. We had the processor, A64FX, which is an ARM-based processor that powers Fugaku. We had done a lot of work with Osaka University on building the digital simulation software, and all it was is putting this together and porting this. It's about twice the speed of a simulator built with GPUs, right? And you can use this now. We also took a very innovative approach to research. We went to the customers. We went to 6 or 7 of them and said, we want to work with you starting building applications on this. So when you saw the press release, Fujifilm, which is, I think, a very innovative company in building some interesting technologies, they were a competitor of Kodak, and Kodak went out of business. Fujifilm completely reinvented itself into being a powerhouse in chemistry-based technologies, and they are now using this to do things that they could not with normal compute. I just talked briefly about Kawasaki before, but this really gives an example. I think lays it out in the picture. It really is leveraging all the 5 technologies that form the base of our platform, and leveraging that to build services that end citizens can use, an average citizen can relate to. So I will, I can go on and on about this because this is something I'm very passionate about, as you can tell. But this is, I think, I'm very, very excited about this wonderful opportunity, and especially with what the Center for Cognitive and Advanced Technologies brings, and the opportunity that brings for us in Fujitsu to help and work with the businesses, with the government, with the citizens of United Kingdom, and together drive the innovation that I think is a wonderful opportunity for both us as well as for businesses here. And we look forward to working with you. Thank you. The last thing is, please do visit our demo areas. We've got a lot of booths that actually will show you that what I'm speaking here is not just PowerPoints, but something that really works. Thank you very much.